Alright, moving on to problem 3. And I don't have my calculator with me, so I'm not going to walk through these things other than to tell you where to go on your calc. You have the formulas in your book and in your notes, so you can look those up. Some key things to keep in mind, though, is the difference between permutation, which is written n permutate r, and the combination n combinations r. So n is the number of items you have in both of these cases, and then R is how big are the groups that you're pulling out of those. Okay, so in this problem we've got 10 people, so that's our n value, and we want to choose them 3 at a time. Okay, so that's our R value. And then the next question is do you do a permutation or a combination? And the way you tell if it's a permutation or a combination is if you have a group of 3 people, let's call them 1, 2, and 3. Okay? If 1, 2, and 3 is the same as 2, 1, 3, a different ordering, then that's a combination. If they are the same, then that's a combination. But if these are different, that's a permutation. And I know what you're thinking. You're right. Now you're thinking, well, hold it. 1, 2, and 3 and 2, 1, and 3, those things certainly are different, then they're all permutations. And the answer is no, not really. Because we just say, hey, you can pick 3 people for your team, and you pick 1, 2, and 3, or you pick 2, 1, and 3, it doesn't matter. You still have the same people on your team. That's the combination. However, if we're talking about a race, as we are in this case, whether you finish first, second, or third matters to each individual. So if you think of these as different people right here, if this is Bill, Joe, and Sue, that is way different than Jill, Bill, and Sue. So if we change the order in which they come in, they get different medals. So the order in which those 3 are coming in to finish the race matters. In that case, it's a permutation. So on your calculators, remember where the permutation is located. You have to first enter how many people are in your group. So you would enter 10. Then you would go into math, and you have to arrow over to the probability menu at the very top. And under probability, you're going to see the NPR choice. And after you've chosen that, your screen will say 10 NPR, and then you enter the 3, and it will tell you how many different ways they can finish the race in first, second, and third out of that 10 people. Okay. With that in mind, that's exactly how you do number 5. This is just a check to see if you can find that function on your calculator. Number 6, same thing. Grab your calculator and choose and pick combination this time when you go to the probability section. And number 4, these are factorials, and we have 70 factorial over 69 factorial. Now your calculator also under probability has the factorial function built into it. However, this problem right here is designed so that your factorial button will not work. In fact, 70 factorial is too big for your calculator to deal with. Remember, that is 70 times 69 times 68 times 67, and it continues all the way down to 1. And that number, when your calculator multiplies that all out by doing 70 factorial, is just too large. So you have to use the definition of factorial to realize that when you have this division problem, what you have is a bunch of 1s here, because 69 over 69 is 1, 68 is a 1, 67 is a 1, and so on down the line. So these are all 1s multiplied times 70. And so your final answer is just 70. Alright, let's do number 7. Now number 7 is rather involved, so I'm going to flip to a blank page so you can see how to do that. In fact, I'm going to pause. No, I won't pause this one. This will be a little bit longer video probably. But let's go ahead and do x minus 3 to the 6th power using Pascal's triangle. The first thing you want to know is this is a binomial. and what we're trying to do is expand it. Okay? And all that means when you say expand it is take x minus 3 and multiply it out however many times it says to do it. In this case it says to multiply it times itself 6 times, and you are more than welcome, if you have the time, to go ahead and start that distributing process. You'd FOIL these two together, then you'd have to distribute that to x minus 3 to that answer, then the following x minus 3 to that answer until you got the final polynomial. And that would take an incredible amount of time, so we created the Binomial Theorem, which is just a pattern that we can follow that can do this for us. Okay, the first thing we have to do is write down Pascal's triangle. And Pascal's triangle, remember, starts with 1, 1, 1, and then we just fill in the gaps. 1's always on the outside. Doing 1 plus 2 gives me 3 here. The next row would be 1. And I look at 1 plus 3 gives me 4. 3 plus 3 is 6, then 4 again, and 1. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. Now this number right here tells you which line or which binomial, how far it will expand a binomial. So in this case we want to expand it by multiplying it 6 times itself, and so this is the line that we want to use. And what that line tells us is the coefficients that we can use as we develop our answer. So after you've expanded Pascal's triangle to the level that you need, your next thing is to write down all of those coefficients. Okay? And I'm going to do a little bit of erasing here so I have some more room. Okay, some of you have a program that actually gives you Pascal's triangle. It's a terrible program, so I wouldn't use it. Just learn to expand it on your own. I don't know why these numbers came back in here, but I lost some stuff, gained some stuff. It's alright, we'll get it all back. Okay, so again, there's our original problem. And these are our coefficients. So, next step is you're just going to write down those coefficients, giving yourself some space between each of them, because we got a lot of terms to fill in. Okay, so those are the coefficients we start with. The next thing we recognize, or should realize, is that whenever we take a polynomial, like AB, and raise it to, let's just raise it to the 5th power, this is how they always go. The first term has an a to the 5th, the second term a to the 4th, third term a to the 3rd, all the way down to, you end up with a to the nothing power, which is just a 1. The b, on the other hand, does the opposite. It goes b to the 0 power, then it goes b to the 1st, b to the 2nd, dot, 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 all the way up to b to the 5th. So we say the a goes in descending order by degree, and the second term, the b, goes in ascending order by the degree of the term. And degree is the exponent on that. So once we realize or remember that they have that pattern, we just use that pattern on the x minus 6. The x is acting like the a, and the b is acting like a negative 3. And so we go, this is pretty easy, and we just write, well, x is going to start off to the 6th power, and negative 3 will start off to the 0. And then x will go down by 1 degree, and the b term, the negative 3, will go up by a degree. And the a term x will go down by a degree, and the b term will go up by a degree. Okay? Notice something about these exponents. They always add up to 6, so it'll help you keep track of what degree goes with who. The next one goes x cubed, and I like to fill these things all at one time and go x squared, x to the 1st, no x's, or x to the 0 if you'd like. The b's, the negative 3's, I was just at b to the 2nd, so that's b to the 3rd, b to the 4th, b to the 5th, and finally b to the 6th. Okay? So there's my polynomials, or my polynomial with all of its terms, and the rest is just doing the math that each term tells us to do. So negative 3 to the 0 power is just a 1. Anything to the 0 is 1. So this is just 1x to the 6. Negative 3 to the first is negative 3. So it's negative 3 times a 6, negative 18, and then we have our x to the 5th. Next one, negative 3 to the second is a 9. 9 times 15, because it's all multiplication, is 135. X to the 4th. The next one I've got negative 3 to the third, that's negative 27. Times a 20 is negative 540. X to the third. And I'm going to run out of brain power here in a little bit. Negative 3 to the fourth is 81, and now I've got to do 81 times 15. And I don't know that one off the top of my head. 40 carrier 4. So that's 120 at a 0. 1215 maybe? You might want to check that. Whatever 15 times 81 is. X squared. This is 243 times 6. That's 243. And then we got to take it times 6. And you continue on with that process. I'm not going to continue on with it because this video is already 11 minutes. So let's just copy that and put it on the answer sheet, and you guys can finish that out, but hopefully you recognize the pattern at this point. So let's go back to this page. Let's paste that guy in there. Do a little cleanup to get rid of these circles I had. But it will continue all the way down. Okay, our next term is going to have an x to the first in it, and our last one will have no x's. In fact, our last one is just going to be whatever negative 3 to the 6th power is. Right, really quickly so we can finish this page out. Number 8, sides of length x minus 4. It's a cube. That means all the sides are the same. And to find the volume of a cube, you take length times width times height. So this is length times width times height. They're all the same because it's cubic. And then you may have to multiply this all together using the quad formula. Or using the quad formula. Multiply all those things together just by distributing. And finally, on this page, the cube root of 0.000064. We're doing cube roots. So we want to see if we can divide this into groups of 3. Oops. Or into 3 groups, rather. Erase that. Because we have to, if it's cube root, it has to be 3 of the same thing multiplied together. And we can see if we take groups of 2 decimal places, they multiply together, so that's going to be 0.0. And then you take the cube root of 64, which is 4. So if you think about it, when you were to multiply 0.04 times 0.04, what happens is you get the 16, but each one has 2 decimal places, so you move it 4. Okay, that gives us a total of 4 decimal places. If we take it times another 0.04, because we're doing cube root, it has to be multiplied together 3 times. That gives us the 64, 16 times 4, and it adds another 2 decimal places, which gives us the total of 6 decimal places that were in the original problem. Alright, so this is problems 3 through 9.